How are you? Today I talk about some most important question answer. Okay, mathematics BSc. Okay, mathematics. Okay. So in this time I talk about first question. This question it is very most important. Okay. So please you note down. This question is examine. Okay. Examine if the set. Okay. If the set of S is a subspace of R 2 by 2. So this S is equal to AB and CD. Okay, belongs to R 2 by 2. Okay, and AB CD. Okay, is equal to 0. So answer. Okay, so S is equal to this set A B C D. Answer. Okay, belongs to R 2 by 2. R 2 by 2 and A B C D is equal to 0. And next, let suppose AB belongs to S. Okay, and A is equal to A1, B1, and C1, and D1, and B is equal to A2, B2, and C2, D2. Okay, next mod A is equal to 0 and mod B is equal to 0, and that is you would find the determinant value. Okay, that is A1 D1 minus C1 B1 is equal to 0. This value, this and this multiply A2 D2 minus C2 B2 is equal to 0. Okay, and next addition A plus B. Okay, A1 this addition. Okay, A plus B is equal to this matrix A1 B1 C1 D1. Okay, and A2 B2 C2 and B2. This value it is A1 A2 B1 plus B2 C1 plus C2 D1 plus D2. Okay, and now now determine value, it is A1 plus A2 and D1 plus D2 and minus C1 plus C2 into B1 plus B2. So this value A1 D1 plus plus okay A1 D2 plus A2 D1 plus A2 D2 minus C1 B1 minus C1 B2 minus B1 C2 minus C2 B2. Okay, C2 B2 and next is equal to A1 B1 plus A2 B2. Okay, A1 D2 plus A2 D1 plus A2 D2 minus C1 B1 minus C1 B2. Okay, minus B1 C2 minus B2 and C2. Okay, this is C2 and next A1 B1 minus C1 B1 plus A2 D2 minus C2 D2. Okay, and plus A1 D2 plus A2 D1 minus C1 B2 minus C2 B1. And always remember this topic, it is okay A1 d1 a1 d2 and plus a2 b1 minus c1 b2 minus c2 b1. Okay, and a1 d2 not equals to c1 b2 and a2 d1 not equals to c2 d1. Okay, and a1 by c1 a1 by c1 not equals to b2 by d2 and b1 by b1 not equals to c2 by a2. Okay, c2 by a2. Okay, next a is equal to this matrix 1 1 2 2. Okay, and b is equal to 3 by 2 1 by 2 and 9 3. This is example. Okay, and a plus b is equal to 5 by 2 3 by 2 and 11 and 5. So not belongs to S. Okay, so S cannot be vector. S cannot be vector subspace. Vector subspace of R 2 by 2. R 2 by 2. Okay, this is very most important question. Okay, and I provide this question answer. Next I talk about some most important questions. Okay, so please do note down. Next question number 2. Okay, this question is shows that. Okay, 1 minute. Okay, this question is shows that the set the set is okay a subspace is a subspace. Okay, shows that the set is be a subspace. Okay, S be a subspace of the vector space of the vector space. Okay, C 0 comma 1. Okay, and where first it is S is equal to F belongs to C 0 to 1 and F of 0 is equal to 0. Okay, how to solve this problem? The answer. Okay, and always remember C 0 on. Okay, is the set of all continuous function of all continuous function of all continuous function of all continuous functions f such that 0 to 1 to r tends to r. The answer here, very easy question. S is equal to f belongs to c is 0 to 1. Okay, and f of 0 is equal to 0 and let f1 f2 belongs to s. Okay, and therefore s is a vector. S is a vector and f10 is equal to 0 and f0 is equal to 0. Subspace of e 0 to 1. Okay, and now f1 plus f2 belongs to s. And next let c belongs to r and f1 belongs to s and cf1 0 is equal to C F1 0 is equal to C into 0 is equal to 0, and so C F1 belongs to S. This is answer. Okay, very easy. This is given some properties and put it this value, and F1 plus F2 belongs to S, and next C belongs to R, and F1 belongs to S, and C F1. Okay, 0 is equal to CF1, 0 is equal to C into 0 is equal to 0, and CF1 belongs to S. Okay, next question. Next question, it is very, very most important. Okay, this question, okay, this question, it is question number 3. Okay, question number 3. Question number 3. Okay, this question is prove that, okay, prove that U plus W is the smallest subspace smallest subspace of V contain containing U and W. Prove that U plus W is the subset. Okay, is the subset. So, prove that U plus W is the smallest subspace of V containing U and W. Answer. Let P be any subspace subspace of V. Okay, and containing and containing the subspace okay, U and W, and next let alpha belongs to U plus W. Okay, and then alpha is equal to E1 plus W1. Okay, and alpha is equal to E1 plus W1, and E1 belongs to U, and W1 W1 belongs to W, and since okay, U subset of P, E1 belongs to P, and W subset of P, W1 belongs to P. Since P is a subspace, P is a subspace of V. Okay, and U1 W1 belongs to P, implies P is a arbitrary P is an arbitrary. Okay, and next this shows that U plus W is the smallest subspace. Okay, U plus W is the smallest subspace. Next question. Okay, this is complete. This question answer. Okay, next I talk about linearly spanned. Okay, linear span. Next question. Question number 4. Okay, this question it is very, very most important. Okay, okay, this topic is if let, okay, this theorem it is let S and P be non-zero, non-empty, sorry, non-empty non-empty subset non-empty subset of a vector space V over a field F and then L S union T is equal to LS plus LT. Okay, LS plus LT. Okay, L S union T is equal to LS plus LT. How to prove this question? Answer. Okay, so L S union T is the set, okay, of all finite linear combination okay, of the elements of S union T. Okay, and next let zeta belongs to LS plus LT. Okay, and then zeta is equal to sigma plus tau. Okay, this is addition. Okay, and for some sigma belongs to LS and tau belongs to LT. Okay, tau belongs to LT. Always remember sigma belongs to LS and tau belongs to LT, and zeta is equal to LT LS 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 LT. Okay, this is tau and this is sigma. Zeta is equal to sigma plus tau. Okay, and next sigma belongs to LS, implies that sigma is equal to C1 alpha 1 plus C2 alpha 2 plus dot 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 CR alpha R. It is infinite linear combinations of vector of S. Okay, this is sigma. Okay, it is the linear combinations of vector of S. Okay, this is finite linear. Always remember this is finite linear. Okay, and tau belongs to LT implies tau is equal to d1 beta 1 plus d2 beta 2 plus dot 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 plus dk beta k. This is some finite linear combinations of vector of T. Okay, it is finite linear combination finite linear combinations of vector of T. Okay, and next therefore zeta, okay, is a finite linear combination okay, of the vector S union T. Okay, and so zeta belongs to L S union T. Okay, and thus zeta belongs to LS plus L of T. Okay, because zeta belongs to sigma plus tau. Okay, and next therefore zeta belongs to L S union T, and therefore LS plus L of T subset L S union T. This is very most important condition. Next topic, S subset of L S belongs to S subset of L S plus L T and T subset of L T implies that T subset of L S plus L of T. Okay, and therefore S union T subset LS. Okay, LS. S union T subset of LS plus L of T. I repeat this topic, S union T. Okay, S union T subset of LS plus L of T. Okay, and LS, L, S union T being the smallest, subspace, of V. Okay, containing S union T, and L S union T subset of LS plus LT. And next this equation, and so first equation LS plus okay, first equation LS plus LT subset of L S union T, and next second equation L of S union T, okay, subset of LS plus L of T. Okay, so this is proved, and these two equation, okay, L of S union T is equal to L of S plus L of T. Okay, L S union T is equal to L of S plus L of T. This is proved. Okay, and always note down, this topic is very most important. In particular, if S and T be subspace S and T be subspace of V, and then L of S is equal to S and L of T is equal to T, and therefore if S and T be subspace of V, and then okay, L of S union T is equal to S plus T. Okay, S plus T by the theorem. L S union T is equal to S plus T. Okay, L S union T is equal to L of S plus L of T. This is answer. Okay. Next topic. Next theorem. Okay, this question is very most important. Okay, this question is very easy. Okay, next question. Question number 5. Okay, next question number 5. This question is, let S be a non-empty non-empty subset. Okay, of a vector space of a vector space V, okay, a field over a field F, okay, and then L S is the LS is the smallest. L is the smallest subspace. L is the smallest subspace, okay, of V, and containing the set S. Okay, proof. This given question is be a non-empty subset of a vector space V and over a field, and L is linear span is the smallest subspace V containing the set of S. Okay, how to prove this problem? So let alpha belongs to S and alpha is equal to 1 alpha. Same to same topic. Being a linear combinations on a finite number, okay, element of S, and S belongs to LS. So alpha belongs to S implies that alpha belongs to LS. Okay, and therefore S subset of LS. This is one equation number. And let zeta belongs to LS. Zeta belongs to LS and eta belongs to LS. Okay, zeta belongs to LS, eta belongs to LS. Next, zeta is equal to C1 alpha 1 plus C2 alpha 2 plus dot 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 plus CR alpha R, and alpha I belongs to S and CI belongs to F. Okay, and next, same to same, zeta is equal to D1 beta 1 plus D2 beta 2 plus dot 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 plus dk beta k, and beta I belongs to S and di belongs to F. Okay, and next let C belongs to F and D belongs to F, and then A zeta plus D eta is equal to C into C1 A1 plus C2 A2 plus dot 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 plus CR AR plus D into D1 beta 1 plus B2 beta 2 plus dot 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 plus dk beta k, and next is equal to P1 alpha 1 plus P2 alpha 2 plus dot 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 plus PR alpha R plus PR minus 1 beta 1 plus PR plus 2 beta 2 plus dot 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 plus PR minus K beta K. Okay, and where Pi, okay, where Pi is equal to Ci, I is equal to 1, 2, 3 dot 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 R belongs to field F, and Pi is equal to D I minus R. Okay, and I is equal to R1 R plus 1 dot 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 R plus K, and belongs to field F, and this is C zeta plus B eta. Okay, is a is a finite combination, is a finite combinations of the element of the elements of S, and therefore, okay, therefore LS belongs to S. and zeta belongs to ls. Okay, and eta belongs to ls. Okay, and implies that c zeta plus d eta belongs to ls. Okay, and for all cd belongs to f. Okay, and this equation, it is ls is a subspace of v containing the set s, containing the set s. Okay, and next, p is, let p be any p be any subspace, p be any subspace of v containing the set, containing the set s. Okay, and next, let zeta belongs to ls. Okay, zeta belongs to ls, and then zeta, it is r1 alpha 1 plus r2 alpha 2 plus dot 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 plus rm alpha m. Okay, and some finite linear combinations of the element of s. Okay, next, this is for some this is, okay, some finite linear, some finite linear combinations of the elements of s. Okay, and alpha I belongs to s, implies that alpha I belongs to p, and I is equal to 1 2 dot 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 m, and p is a subspace since subspace p is a subspace, ri belongs to f. Okay, and alpha I belongs to p, and next implies that ri alpha I belongs to p, and for I is equal to 1 2 dot 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 m, and therefore zeta belongs to ls. Okay, and implies that zeta belongs to p, and therefore ls subset of p. Okay, this is proof that ls is a smallest subspace of v containing the set s. This is proved. Okay, so this question, it is very most important. Okay, let S be a non-empty subset of a vector space V over a field F, then Ls is the smallest subspace of V containing the set S. Okay, next question. Okay, question number 6. Okay, question number 6. Okay, next question, it is very most important question. Okay, this question is definite linear span. Okay, and find the linear span of s is equal to 1 2 and 3 1. Okay, how to solve this problem? Okay, so answer, let s is equal to alpha 1 alpha 2 dot 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 alpha n. Okay, be a set, be a set. Okay, be a set. Okay, be a set of vector, be a set of vectors, and be a subspace. So be a subset of vector, be a subset of vector space V, vector space V over a field, over a field F. Okay, vector space V over a field F, and then the linear span, the linear spans of S, denoted by ls, denoted by ls, and and defined and defined by ls is equal to c1 alpha 1 plus c2 alpha 2 plus dot 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 cn alpha n. Okay, and c1 c2 c3 dot 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 cn belongs to field F. Okay, and ls is equal to c1 into this element and c2 into this element. So c1 into 1 comma 2 plus c2 into 3 comma 1. Okay, and c1 c2 belongs to R, and is equal to c1 plus 3 c2 and 2 c1 plus c2, because this value multiply and this value multiply. Put it this value, next this value multiply and this value multiply, this is value. Okay, plus this value, and c1 c2 belongs to R, and is equal to, this is x comma y. Okay, x comma y, and xy belongs to R2. Okay, it is R2, and this element 1 0 0 1, this is R2 elements. Okay, and R3 elements, this is 1 0 0 0 1 0 and 0 0 1, this is R3 elements. Okay, so thank you. All question, it is very very most important. If you not understand any problem, any question, so please you asked me. Okay, I always, any problem, any question, I try how to solve this question solve. Okay, and if you not understand any question answer, so please you comment me. Okay, thank you, take care, goodbye.